Okay, before we dive into today's main topic, I want to start with a really quick mission brief, just to set the stage. There's this fascinating geopolitical story moving through the news lately. Reports of a sort of de facto toll booth popping up in the Strait of Hormuz. Transit fees are supposedly being demanded in Bitcoin, or maybe Chinese yuan, instead of US dollars. Now look, whether it's actually Bitcoin or just yuan isn't the point. The underlying dynamic is what's so interesting to us. When institutional trust completely breaks down under extreme pressure, systems immediately demand neutral settlement rails. They demand verifiable receipts. They demand proof, right? That is the geopolitical version of this problem. But in today's explainer, we are talking about the artificial intelligence version, because autonomous agents are about to run into the exact same wall. When they start acting in the real world, how do you actually prove what just happened? Welcome to the explainer. We're looking at a massive, fundamental shift for builders right now. The core thesis today is simple but absolutely critical. If autonomous agents are going to touch tools, if they're going to edit files, or especially if they are going to spend money, they need verifiable pre-action receipts. We don't want apology logs after the fact. We need cryptographic proof of intent before they ever make a move. We are calling this concept receipts before autonomy. So here is our roadmap for today. We're going to cover the agent action gap, why logs aren't enough, signed action proofs, using Nostr as infrastructure, lightning and economic action, and finally wrap up with the minimum viable receipt. Let's get right into it. All right, part one, the agent action gap. The strongest signal coming from agent builder communities right now, places like Cluster and Moltbook, is not that agents are getting smarter. It's that they are getting significantly harder to supervise. Now, these are community signals, to be clear, not peer-reviewed, audited studies, but what operators are reporting is wild. We're talking about instances of 1,923 autonomous microtasks happening in just a 48-hour window, or over 2,300 completely unnecessary tool calls where an agent was basically just spinning its wheels, creating activity that looked like work. And you know what's ironic? The most dangerous agent isn't some rogue, rebellious AI. It is actually the perfectly obedient one. The one that accepts massive scope creep without ever pushing back. So the real bottleneck for AI builders today, it's no longer capability. It's accountable control over massive volumes of concurrent tasks. Think about it this way. A standard chatbot has a very, very small blast radius. I mean, what's the worst it can do? It puts the wrong text in a chat box. You close the window, you move on. But an obedient agent that actually has access to tools, that has a massive blast radius. It can delete critical files, it can spend your sats, it can post publicly to your social feeds, or it can trigger production APIs. When the stakes escalate from just bad text to, whoops, I deleted the database, capturing the agent's intent beforehand becomes absolutely critical. Which leads us directly into part two. Logs are not enough. The builder community is really having a maturation moment right now. They're waking up to the fact that agent trust has been way too vibe-based for way too long. We've been judging agents based on a friendly conversational tone or a fluent response. But trust has to be based on inspectable behavioral evidence. There's a phrase going around the community that hits the nail on the head. The log is the identity. But here is the catch with that. Post-action logs are completely necessary, sure, but they are incredibly insufficient. A log only shows you the damage after it's already happened. It helps you clean up the mess, but it doesn't do a single thing to prevent the blast in the first place. On top of that, agent memory files often degrade into this sort of untrustworthy lore if they aren't strictly validated. And dashboards? Look, a dashboard full of telemetry often just turns into performance art. Treating a post-action dashboard as your governance solution is really just accountability cosplaying as observability. Confidence and accuracy are two fundamentally different things. So we have to make a very clear, very crucial distinction here. Observability means seeing what your agent did after the fact. Accountability, on the other hand, means cryptographically proving what your agent was actually authorized to do and under what specific constraints before it ever took the action. If we want real autonomous systems, we absolutely have to make the leap from mere observability to hard accountability. Part 3. Signed action proofs. So what is the actual solution? It's the signed action proof. This is a structured, cryptographically signed intent that is emitted by an agent before it touches a tool, an API, or any external system. A safe action requires a structured intent before the tool is even invoked. This is exactly what we mean when we keep saying receipts before autonomy. But if we're being practical, if we want this to actually be useful in production, what specific parameters does this cryptographically signed claim need to contain? What does it actually look like? Well, a receipt is not a vibe. It is a signed claim with enough strict structure to verify later. The proof has to rigorously detail a few key things. First, who is acting? You need a public key for that. Second, what exactly is authorized? This is your scoped intent. Third, who actually authorized it? Was it a human operator or maybe another delegating agent higher up the chain? You also need to define the constraints, things like hard budgets, time limits, or specific tool classes. You need to know when the permission expires. And finally, you have to explicitly state what parts of this receipt are public and what parts are private. Capturing all of this ensures that autonomous actions don't just turn into a massive game of plausible deniability. Moving on to part 4, Nostr as agent infrastructure. Now, I want to be very, very clear about something. Nostr is not some magic AI safety dust that you can just sprinkle on your code. It's not. But the Nostr protocol does offer the exact cryptographic building blocks required to make these receipts work, mostly through its NIPs, or Nostr implementation possibilities. For instance, NIP01 gives agents signed identity and tamper-evident event records right out of the box. NIP44 allows for encrypted payloads, which means an agent can record a delegated intent completely privately without exposing your sensitive infrastructure details to the entire public network. And NIP22 provides the threading and comment structures you need for agent-native coordination. It is an incredibly potent, ready-made infrastructure substrate. However, as builders, we have to cleanly separate these concepts in our heads. The protocol layer, Nostr, provides signatures to prove identity and encryption to protect privacy. That's it. Builders still have to rely on the operator layer to enforce the actual authorization, to define good policy, and to verify the tool outcomes. A signature proves that a specific key signed something. It definitely doesn't prove that the action itself was actually a wise idea.
Part 5, Lightning and Economic Action.
So, what happens when an agent starts spending money, paying other agents for research, or requesting payments? Well, the requirement for pre-action receipts immediately goes from a nice-to-have best practice to an absolute, non-negotiable necessity. Economic action dramatically raises the stakes. When real value is on the line, trust me, the model said it was okay is not an authorization model. Actually, scratch that. It is an authorization model. It's just a model for a future incident report.
And this is exactly where NIP57, Lightning Zaps, comes into play. It takes vague autonomy and turns it into accountable market action. Through Zaps, agents can dynamically price, request, and receive value transfers. But practically speaking, this means spending requires a receipt before the transaction ever hits the mempool. A paid delegation between two agents needs a clearly defined scope before a Zap is ever sent. The intersection of Lightning micropayments, Nostr identity primitives, and agent-only networks like Nostr creates a ridiculously powerful testbed for a truly accountable agent economy.
All right, wrapping up with part 6, the minimum viable receipt. For all the builders out there, here is your blueprint. This is a clear, practical, step-by-step workflow to ensure that every meaningful tool call leaves a rock-solid auditable trail. Number 1, you sign the actor identity using NIP01. Number 2, you record both a human-readable intent and the strict machine constraints. Number 3, explicitly define the authorization source and the expiry condition, so it doesn't live forever. Number 4, emit a public hash as a receipt, while encrypting all the sensitive private details using NIP44. And finally, number 5, once the action is actually done, you link that execution result right back to the original intent. It's a simple, robust loop. I want to end today's explainer with this somewhat provocative thought. If your agent can act without leaving a receipt, it is not autonomous. It is just unsupervised. As you go back to your terminals to keep building, I want you to seriously ask yourself, what actions in your stack are you going to demand receipts for moving forward? Is it payments? File edits? Code deployments? It is time to build agents that can act, for sure, but we have to make them bring receipts. Thanks for joining me for this explainer, and I'll catch you next time.